Welcome back to the Deep Dive. Today we are wading into a really technical battleground, one that's shaping the future of how you interact with AI, even if you don't realize it yet. For the last couple of years, all the excitement, has been about what AI agents can
Their
think.
reasoning capabilities, right?
Yeah, their ability to generate text, to generate code. But the new frontier is, it's about what agents can build.
Exactly. Because the moment an agent needs to do something practical for you, something real,
Like what?
well, whether it's managing complex data, booking a service for you, or, guiding you through some kind of enterprise workflow, the interface is no longer a luxury.
It becomes a bottleneck.
It becomes the critical security and usability bottleneck. We're moving beyond just text prompts and into, well, dynamically generated graphical user interfaces, agent UIs.
And we have two massive emerging standards really fighting for dominance in this space.
Do
On one side, we have Google's open source A2UI. That's the agent-to-user interface.
And on the other, you have the more web-centric approach, the Model Context Protocol, which most people know as MCP apps.
Favored by players like OpenAI and Anthropic.
That's right. So our mission today is to, cut through this alphabet soup, A2UI, MCP, A2A, AGUI.
It's a lot of acronyms.
It is. We need to conduct a deep architectural review. We need to understand the fundamental philosophy behind each approach.
Because this isn't just a technical debate, is it?
No, not at all. It's a strategic choice, a choice that dictates the future of security, of application development, and crucially, how rich and seamless your generative AI experience actually feels.
The core problem here is just fascinating, so complex.
Yeah.
We're talking about this idea of a multi-agent mesh.
Right.
You have these powerful AI models running remotely, maybe across different organizations, different trust boundaries.
And they need to securely present a rich, interactive interface inside your application.
And if that interface is clunky, if it's inefficient, or worse, insecure.
The entire agent framework fails. The whole thing falls apart.
And we've all felt this pain point. I mean, we've all been there with a chat system that just sends back text.
Oh, absolutely. Let's use that classic example from the sources. Booking a restaurant reservation through a conversational agent.
The old way, the text-only way, is it's excruciating. It relies on this high latency back and forth dialogue.
Right.
You start by typing, book a table for two.
And the agent, because it can only respond in natural language, it has to kind of fish for all the required parameters.
So it comes back with understood. For what day and at what time are you looking?
And you type tomorrow, maybe 7 p.m. But now the conversation just hits a snag.
Because the agent might need to verify party size, handle availability, confirm special requests.
So it replies, unfortunately, 7 p.m. is fully booked. We have a 6:30 p.m. and an 8:45 p.m. slot. Or would you like to check a different day?
It's this tedious conversational dance. It forces you to translate structured inputs like a date, a time into unstructured text.
It increases your cognitive load, the error rates go up, it's slow, it's inefficient, and frankly, it's disrespectful of the user's time.
Okay, so now let's imagine the A2UI solution. The moment you state your intent, book a table for two, the agent recognizes this.
It recognizes it's a structured data collection task, not just a chat query.
So instead of sending back more text,
It instantly generates a simple bespoke form, and this form doesn't rely on you typing for those crucial parameters.
what does it have?
It would include specific, high-fidelity interactive components, so a date picker widget that immediately shows you available days,
Okay.
a time selector dropdown, maybe it's color-coded by availability, and a clear, single-purpose submit button.
The efficiency gains are just immediate.
They are. You are no longer interacting with text prompts. You're interacting with UI components that are context-aware, that are stateful, and designed for optimal input.
You just adjust the date on a calendar widget, and you confirm the selection instantly.
It completely bypasses that slow, multi-turn text dialogue and that instantaneous creation of a context-aware interface.
Making the agent feel like an on-demand application developer.
That is the objective. That's what standards like A2UI are designed to achieve. It allows the agent to deliver an experience that feels exactly like a dedicated mobile app.
But, and this is the key, without a developer having to hard code the UI for every single possible conversational path.
Exactly. The UI is generated dynamically based on the current state and intent of the conversation.
Okay, let's really unpack Google's specific answer to this problem. A2UI, the agent-to-user interface. We need to go beyond the definition and really get into the core philosophy here.
Fundamentally, A2UI is an open source project, and it's a declarative UI protocol, a standard.
Okay.
It's currently available in a V0.8 public preview, and it's under the Apache 2.0 license, so it's very permissive.
And the idea is that A2UI provides a standardized language for agents to communicate their UI needs to any client app.
That's it. And the key innovation, the thing that really separates it from traditional web approaches, is that this language is declarative. It's not executable.
So agents are not sending JavaScript or full HTML that the client then has to, run.
Precisely. The agent speaks UI by generating a standardized JSON format. And this JSON, it describes the intent of the interface, what components are needed, where they go, what data they need, rather than sending the actual code to execute them.
Which leads us directly to the foundational mantra of the whole project. And this says a lot about their priorities.
It does.
A2UI aims to transmit UI that is safe like data, but expressive like code.
And that philosophy, that single line, dictates every single design choice they made after that.
How so?
Well, if you treat the UI request as verifiable, structured data as JSON, you can run it through all sorts of stringent security checks right on the client.
But if you treat it as executable code?
You inherently open yourself up to all the security risks of executing unknown, potentially adversarial code that's been generated by an LLM.
Okay, let's dig into those core design principles, starting with that security advantage. Because this feels like the deal breaker for enterprise adoption, right?
Yep.
Especially with remote agents operating across severe trust boundaries.
The security-first architecture is paramount. It's number one. Since A2UI is just a declarative data format, it immediately mitigates those huge endemic risks you get with LLM output.
Like UI injection, cross-site scripting, XSS.
Exactly. Or the execution of arbitrary scripts. You simply cannot generate an XSS attack through a JSON payload that only declares the existence of a button. It's not possible.
But the JSON itself still needs to be verified, right? How does the client app make sure the remote agent isn't asking for some kind of, nefarious component that could compromise the application?
That is the critical security boundary. The client side maintains what the sources call a catalog of trusted, pre-approved UI components.
So it's like a strict allow list.
It is exactly that. This catalog might contain a very limited set of components: card, button, text field, date picker, slider. The agent can only request components that are explicitly in this client-controlled and audited catalog.
So it sounds like a form of capability-based security. The agent just doesn't have the capability to render anything it wants.
That's the insight. Its expressiveness is strictly limited by the client's internal security policy. The control is placed firmly in the hands of the application developer.
The developer who audits and maintains that local catalog.
Yes. This means the client application defines its own trust ladders, its own security policies, knowing with absolute certainty what can and cannot be rendered. This is fundamentally different from trying to, sanitize a big, opaque blob of third-party HTML after the fact.
Which is a never-ending security battle.
Always.
Okay, so let's move to the structural principles. A2UI is also designed to be LLM-friendly and incrementally updatable. This seems like a really important technical choice aimed at optimizing for the generative model itself.
It is. This is a deep dive into structured generation. So when you look at how traditional UIs, like an HTML DOM, are built, they form these deeply nested recursive trees.
Right.
An LLM trying to generate a perfect, complex, deeply nested JSON tree all in one go, it often fails. It creates syntax errors or, mismatched closing tags.
It's just hard for the model to hold that whole structure in its context all at once.
Correct. So A2UI avoids this problem. It represents the UI as a flat list of components with ID references.
Can you give an example of that?
Sure. So instead of nesting a button inside a card, which is inside a layout container, the agent just declares, here is component A, the container, here's component B, the card, here is component C, the button.
And it links them.
And component B explicitly references component C as its child using a simple ID. This flat structure is vastly easier for a model like Gemini to generate accurately.
And for the user, what does that mean? Speed, responsiveness.
It enables progressive rendering. The client app doesn't have to wait for the LLM to finish generating the entire perfect JSON payload.
So as the list comes in.
As the agent completes the list, say, sending the container, then the header, then the first text field, the client can start rendering those results instantly. The interface assembles in real time, rather than just popping up all at once.
Which feels much more fluid.
A far more responsive and fluid user experience, yes.
And the incrementally updatable part means the agent can refine the interface without starting from scratch.
Exactly. If you update one text field, the agent only needs to send a tiny JSON patch that references the component ID that needs to change. It doesn't have to resend the whole complex tree.
That capability must be massive for maintaining context in stateful workflows.
It is. Like in the cab booking example we'll get to later, it's crucial.
Okay, the last principle, and this is arguably the most critical competitive differentiator, is its framework-agnostic portability, the so-called native-first approach.
This is the core architectural split with the competing standards. A2UI enforces a really strong separation between the UI structure, that's the abstract description sent by the remote agent, and the UI implementation.
The implementation being how the client app actually draws the pixels on the screen.
Exactly. So the agent only cares about the abstract intent. It just says, I need a type, date picker, and a type submit button.
That's its only concern.
That's it. The client application, whether it's a Flutter mobile app, an Angular desktop app, a web component library, or a future Swift UI app, takes that abstract description and maps it to its own local, native, high-fidelity widgets.
So me, as a developer, I get to decide what that abstract submit button looks and feels like.
You do. If your app uses material design, it gets a material button. If it's an iOS app, it gets a native iOS button that follows Apple's human interface guidelines.
So a single A2UI JSON payload can be rendered natively across any front-end tech.
Consistently and natively. And this is critical for two big reasons. One, it preserves the customer's established brand identity and styling perfectly.
And two,
it ensures that all your accessibility features like screen reader compatibility and high contrast modes are automatically inherited from the host application's framework.
that immediately solves that problem of visual jank, that sort of disjointed feeling you get when third-party content is just injected into your otherwise seamless app.
It's designed to make the agent's output completely indistinguishable from the host app's own native UI components. The client owns the rendering, the agent just owns the intent.
Okay, let's solidify this. Walk us through the architecture flow, the 4 phases that disconnects the UI generation from the actual execution.
Right. The process starts with phase 1 generation. The AI agent, usually a large model like Gemini, gets the user input, and it generates the A2UI response.
And that's the structured JSON payload.
Correct. Detailing the UI components, the data model, the agent can create this layout from scratch, or it can fill in pre-existing design templates.
And that JSON needs to get from the remote agent to the client app. That's phase 2, transport.
Yep. The JSON message is sent across the wire. This can happen over specialized, secure channels like the A2A protocol, that's agent to agent, or the AGUI protocol.
Or maybe even just a standard REST API.
Potentially, yes. Full REST support is a roadmap goal. A2UI is transport agnostic. It's the cargo, not the road.
The client app gets the data. Phase 3, resolution. This is the security step, the firewall moment.
It is. The client's A2UI renderer library immediately parses the incoming JSON. It checks the structure for validity, and most importantly, it checks the list of components against its local, trusted catalog.
And if the remote agent requests something that's not approved?
The rendering fails safely. The client only proceeds on data that has been fully vetted against its internal trust policies.
And finally, phase 4, rendering. The abstract becomes concrete.
The render converts those abstract component definitions, that type text field, into the concrete native implementation. That text field becomes the high-fidelity input widget specific to Flutter or React or Angular.
So the user sees a secure, high-quality native interface delivered dynamically by a remote AI agent, all within their existing application.
That's the flow.
So we've established this secure, native-first foundation for A2UI. The question now is, how does this architecture stack up against the dominant players in the agent ecosystem, the ones who've, chosen a different path?
Right.
Let's look at the competition in Section 2, specifically the Web-Centric MCP apps.
This comparison is crucial. It really is, because it represents a fundamental strategic difference in how the future of applications will be built.
So the alternative school of thought is based on the Model Context Protocol, or MCP.
Correct. Which originated with Anthropic and is broadly supported by OpenAI.
And the specific standard here is the MCP Apps Extension, or SEP 1865. This standardizes how interactive UIs are returned within that broader MCP structure.
Yeah.
How did they approach the problem?
MCP apps takes a very explicitly web-based or resource fetching approach.
Okay.
When their agent needs to display a UI, it does not send a blueprint. It returns the UI as a resource, usually accessed via a we.uri.
And that resource is typically pre-built HTML content.
Yes, which the host application then renders inside a sandboxed iframe.
So the agent is basically generating a mini web page full HTML, maybe some JavaScript, and the host app just opens it in a little secure window.
Exactly. The sandbox is there to provide security isolation, right? To prevent the HTML.js from accessing the host application's data.
And this approach has a clear strategic advantage: speed and familiarity.
It does. Web standards, HTML, CSS, JavaScript, they're mature. The tooling is ubiquitous, and developers can leverage existing browser plugins and extensions very easily.
That's a powerful point. If you want the fastest time to market for some new interactive element, generating standard HTML is probably quicker than integrating a whole new declarative protocol like A2UI.
That's the rationale. But this is where Google and the A2UI sources really highlight the critical architectural drawbacks of that iframe approach.
They point out that sandboxed iframes are inherently heavy. They introduce performance overhead, and they're difficult to integrate visually. Why is that? Why is visual consistency so hard with iframes?
Because the content inside the iframe is an opaque payload. The host application has minimal control over the styling, the fonts, the component structure inside that sandboxed web view.
So you end up with this visually disjointed experience.
A web bubble floating inside your native map.
Yeah.
And it often breaks the user's immersion and the brand experience.
Okay, let's go back to our analogy. If A2UI is the agent sending a blueprint of native components to be built by your trusted local craftsman, what is MCP apps sending?
MCP apps is retrieving an opaque payload. It's like a remote contractor sending you a finished, prefabricated shipping container, the iframe, with its internal HTML and styling, and saying, here, stick this on your property.
It's fast to deploy.
Very fast.
Yeah.
But you have very limited ability to match the color palette or the button radius or the accessibility standards of your main structure.
Whereas the A2UI approach, by sending that verifiable JSON data, guarantees the UI perfectly inherits the host app's styling and brand guidelines.
And accessibility features, because the client application is the one actually rendering the final pixels using its own trusted libraries.
So for large enterprises or, companies focused on a unified, high-quality user experience, the visual consistency of A2UI is a huge selling point.
It's often prioritized over the immediate expressive flexibility of full HTML and JavaScript.
That raises a crucial question, though: the expressiveness. If the client controls the component catalog, that whitelist of things the agent can ask for, doesn't that fundamentally limit the agent's creativity?
It does.
Couldn't MCP apps, by allowing full HTML.js in its sandbox, enable far more novel and unbounded interactions?
That is the core trade-off. You're absolutely right. A2UI deliberately sacrifices unbounded expressiveness for guaranteed security and consistency.
So if an agent wants to generate some completely new, bespoke visualization using, say, WebGL,
A2UI currently restricts that unless the client explicitly adds that custom component to its trusted catalog first.
So the argument for A2UI is that for, 95% of practical agent workflows, forms, dashboards, buttons, maps, you don't need that unbounded creativity.
You don't. You need secure, reliable, high-quality integration.
And for high-stakes environments like finance or healthcare, where you have to guarantee compliance,
the ability to formally audit the component catalog and the declarative structure is worth the trade-off in creative freedom. Google's design is clearly focused on the reliability and trust required by enterprise and multi-agent systems. Safety trumps novelty.
Okay, let's clarify the relationship between A2UI and the other protocols in this growing ecosystem. All the acronyms, A2A, AGUI, it can feel like alphabet soup.
Let's use a metaphor to clarify this.
Yeah.
Think of A2UI as the language, or the content. It's the precise description of what needs to be displayed.
But it doesn't handle the connection itself.
No, that's where the other protocols come in. The A2A, protocol agent-to-agent, that's the foundation for secure multi-agent collaboration. It defines the rules for two distinct remote agents to talk to each other. So think of A2A as the secure highway or the trusted envelope. An A2UI message travels inside that envelope.
And what about AGUI from Copilot Kit? Where does that fit in?
AGUI, the Agent User Interaction Protocol, it handles all the necessary scaffolding. This is the traffic manager or the post office.
So it manages state synchronization, chat history.
Right. It handles user input routing, ensures continuity, and crucially, AGUI fully supports the A2UI specification.
Which means developers don't have to choose between a framework like CopiloKit and the A2UI standard.
Exactly. They use the framework, AGUI, to handle the state and history, and they use A2UI as the standardized language to describe the dynamic UI components that get generated within that conversation.
They work together.
Perfectly. And we already see this in action. The GenUI SDK for Flutter explicitly uses A2UI under the covers as its UI declaration format. This proves A2UI is designed to plug into and standardize the generative UI part of the larger agent stack.
Theory is one thing, but seeing these principles in action really brings A2UI to life. Let's move to Section 3 and explore the specific, detailed use cases from the source material, starting with dynamic data collection and the Smart Budget Tracker dashboard.
This scenario really highlights A2UI's ability to create adaptive workflows where the interface itself is a product of data analysis.
So you prompt the agent with a huge set of your transaction data.
Right. And a request. Generate a dashboard summarizing my spending and identify areas where I can cut back.
If that agent just responded with text, you'd get this long, hard-to-parse list of categories and numbers. It would be overwhelming and static.
It would. But with A2UI, the agent instantly generates a bespoke interactive dashboard. It composes this view using a variety of components from the client's trusted catalog, optimizing the display for data visualization and for interaction.
So what are some of the specific interactive components the agent generates on the fly?
Well, the agent might instantly create an interactive slider component that visually represents your expense distribution per category.
So you can see right away, restaurants is 40% of my spending, just by looking at the slider.
Exactly. And it also includes the ability to act on that data immediately without another text prompt.
So,
The agent generates editable limits with inline text fields, letting you change your dining out budget right on the spot. It can include date range selectors, granular category filters, maybe using toggle switches.
the key takeaway here is just efficiency. The user is engaging directly with visual components, adjusting budgets with sliders, filtering with checkboxes.
It eliminates the need for the agent to ask all those follow-up questions in text. The agent presents the interface needed to handle the complex state immediately.
And that rapid generation is critical for enterprise agents that have to generate these complex visualizations or dashboards on the fly.
Totally. The UI is custom tailored to that specific query, and it adapts instantly.
Okay, let's look at an even more complex example.
Yeah.
The cab booking system. This is where A2UI's ability to manage stateful processes with real-time incremental updates really comes into play.
This is where that incremental update feature just shines. So we start in the pre-booking phase, or planning mode. The user has requested a cab.
And the agent knows that location, vehicle choice, and pricing are all required before you can confirm.
Right. So walk us through the UI requirements the agent generates for this planning mode.
Well, it's a highly functional interface. It probably uses map components. So you have an interactive map with draggable pickup and destination pins.
Allowing the user to fine-tune the location visually.
Yes. And it needs structured data input, so it generates 2 address input fields, maybe with autocomplete functionality.
And the vehicle selector is a complex component in itself,
Yeah.
right? It needs to integrate with external data.
Absolutely. The agent generates a horizontal vehicle selector showing real-time, frequently updated data like current pricing, ETAs like 3 months away, next to high-quality vehicle icons.
And it could even generate toggles for user preferences, like optimizing for the shortest versus fastest route.
And the entire interface is structured using A2UI's declarative language. Now comes the moment of truth. The user taps Confirm Booking, and the state has to change from planning to active. How does A2UI handle this without that jarring screen flicker or reload?
This is the elegance of the declarative incremental update. The agent gets the confirmation, it sends an update to the cab service, and then it immediately sends a new A2UI message that dictates only the necessary updates.
So it can transition the existing UI without clearing the whole screen or reloading a new iframe.
Exactly.
How does the interface change for this live tracking phase?
The agent updates it incrementally. The interactive map is retained, but now it updates to show a moving car icon for the driver's live location.
And the functional components get swapped out.
They do. The vehicle selector is replaced by a driver information card, which has the driver's name, their rating, plate number, and maybe a countdown timer arriving in 1 meter 58.
And the tools change dynamically too. Planning tools are replaced with active communication tools.
The new A2UI payload adds one-tap buttons like call driver, message driver, and a prominent SOS button for emergencies. The agent manages this highly complex, stateful, and time-critical process entirely through declarative JSON messages.
And it guarantees that native look and feel the entire time.
It does.
This scenario perfectly illustrates the role of A2UI in a multi-agent mesh.
It really confirms that interoperability. The main orchestrator agent you're chatting with, it delegates the booking responsibility to a specialized remote agent, the cab company's agent.
And that remote agent, running on a different server, securely returns the A2UI payload.
Which is then rendered securely inside your main application window, because the message is just verifiable, declarative JSON. It respects all the security boundaries.
So to synthesize these powerful use cases, A2UI enables three major categories of agentic function that were previously really difficult. Dynamic data collection, like instant complex forms, remote sub-agents, so secure delegation of UI, and an adaptive workflows, like that stateful cab tracking system.
It fundamentally removes the technical constraint that the agent must be tightly coupled to the client application's view layer to produce a rich UI. And that decoupling is absolutely essential for the future of decentralized multi-agent architectures.
This all sets the stage for really rapid adoption. Let's move to Section 4 and look at the current status, adoption, and roadmap for A2UI. If I'm a developer today, where does this project stand?
A2UI is currently positioned strategically in v0.8. It's a public preview.
What does that signify?
It means the specification and the initial implementations are stable. They've been hardened through internal usage at Google, but the spec is still open to community feedback and evolution as it drives toward that critical v1.0 stabilization point.
And the openness is key. It's open source under the very permissive Apache 2.0 license.
Right, which signals Google's commitment to making this an industry standard, not just some proprietary internal tool.
The project's success really depends on contributions, especially in expanding the client libraries.
It does. Right now, the official client libraries include support for Flutter, web components like Lit, and Angular. This covers a big part of Google's own ecosystem, but it leaves room for broader integration.
And the path for adoption starts with just cloning the GitHub repository-Google A2UI.get.
Yes, and developers can immediately run samples like the Restaurant Finder demo to see the full pipeline in action. That demo is a perfect illustration of the stack.
He uses Python for the agent and Lit for the client, right?
A Python agent on the back end generating the A2UI payload, and a Lit web component renderer on the front end consuming and displaying that declarative JSON.
Okay, now for the crucial validation points. The key collaborators and production uses. This wasn't developed in a vacuum. It was built to solve specific, high-stakes internal problems from day one. Let's start with Opal.
Opal is Google's massive internal mini-app platform. It serves hundreds of thousands of people inside the company. And Opal uses A2UI to enable rapid prototyping and the integration of generative UI that's custom-made for each use case. This internal proving ground validates A2UI's ability to handle really high-velocity development and deployment.
It lets engineers build and share AI mini-apps quickly.
Exactly. And the declarative nature ensures consistency across all those rapidly developed tools.
So that velocity validation is essential. But velocity can often clash with security, which brings us to Gemini Enterprise.
For Gemini Enterprise, the stakes are much, much higher. A2UI is integrated specifically to allow custom enterprise agents, which handle sensitive data and proprietary workflows, to render these rich interactive UIs.
So customers need their agents to do things like generate internal expense reports or approval dashboards.
Right. And A2UI dramatically accelerates that workflow automation, but with the necessary security assurances built in via that component catalog. This use case validates A2UI's core security promise.
And then there's the broad internal standardization effort. AI-powered Google.
A2UI provides the standardized kind of lingua franca for AI agents internally to exchange UIs, not just text or simple data objects.
And that standardization is critical for internal interoperability.
It is. It supports complex multi-agent workflows across all these different internal front ends.
Now, outside of Google, the ecosystem support is growing fast. The synergy we talked about earlier with AGUI Copilot Kit seems really strategic for external developers.
Oh, absolutely. Copilot Kit is one of the leading tools for building rich, full-stack agentic applications, and they built day zero compatibility for A2UI.
So any developer using the AGUI protocol for state sync and chat history automatically has A2UI available to them.
They have it available as the standardized data format for generating dynamic interfaces right within that environment.
And for mobile developers, the Flutter GenUI SDK is another major validation point.
It is. The GenUI SDK for Flutter uses A2UI as the default UI declaration format between remote server-side agents and the application. This guarantees mobile users, whether they're on Android or iOS, get a high-quality, native-feeling experience.
And it uses the client's own trusted, audited widget catalog.
That's right. This all confirms that A2UI is positioned both as a core internal standard, which validates its architecture, and as a foundational open standard that is immediately pluggable into major external agent stacks.
Which naturally leads us to the future roadmap. The project is actively seeking community contributions to stabilize the spec and, aggressively expand its reach.
Especially to challenge the dominance of the web-centric solutions.
What are the key areas for community focus?
The major area is more renderers. They are explicitly seeking official, high-fidelity client implementations for critical, high-volume frameworks.
Like what?
Like React for web apps, Jetpack Compose for native Android, and iOS, SwiftUI. Capturing the React developer base is essential for broad web adoption outside of Google's immediate ecosystem.
They're also looking for additional transports.
Yes, specifically mentioning full support for standard REST and other common API patterns to ensure maximum flexibility. And finally, integrating A2UI as a native output format for more widely used agent frameworks.
Like GenKit and LangGraph.
Exactly. The ultimate ambition is clearly to make A2UI the default, standardized communication layer for declarative UI exchange across the entire generative stack.
This has been an incredibly detailed deep dive into what is quickly becoming the most crucial architectural choice in AI development. To synthesize everything in Section 5, the core takeaway for every developer, every enterprise leader, every designer, is that the future of agentic interaction boils down to a fundamental architectural choice.
A choice driven by a prioritization of values.
And that choice pits the web-centric sandbox approach,
where you get speed and unbounded expressiveness by returning an opaque executable resource, the iframe,
against the native-first blueprint approach of A2UI.
Correct.
And A2UI's commitment to sending a declarative JSON description rendered by the client's own trusted components, it resolves the biggest pain points facing agent adoption today.
Guaranteed security and seamless visual integration.
By allowing remote agents to produce safe, rich, and native UIs, A2UI removes the barrier that previously forced agents into those clunky text-only modes or visually jarring web bubbles.
We are now talking about agents capable of instantly generating complex applications, cab booking systems, customized data visualization dashboards, enterprise approval forms.
All with the speed and quality of a native application.
The ability for an agent to truly speak UI is what transforms the user experience from a low-fidelity, multi-turn text conversation about a task
into an instant, high-fidelity, adaptive interaction through a bespoke interface. This shift is it's a game changer for productivity and for trust.
Which brings us to our final provocative thought. Our discussion has centered on the agent generating the UI for you, the client application, and the security benefits you get from using declarative JSON over executable code.
But if we accept that cab booking use case, which involve location data, time sync, payment estimates, we realize the generated UI is not just decoration.
It's a verifiable artifact of the transaction.
And this opens up a profound possibility for security and compliance.
Given that A2UI provides a structured, verifiable blueprint, what if this declarative UI format could become the new auditable security boundary?
What does that mean in practice?
It means that instead of just relying on the client's renderer to check the component catalog, we could formally audit the requested interaction flow, the buttons, the inputs, the required data bindings at the protocol level.
So this raises a really important question.
Could A2UI's blueprint structure enable a system where the agent's requested user interaction is verifiable and compliant before the user ever clicks a single button, effectively standardizing trust for agents operating in highly regulated fields like finance or healthcare?
It changes the UI from an aesthetic element into a formal, verifiable contract.
Exactly, a contract between the agent and the user.